Welcome back everyone to my next video in the AI Oops from Scratch series. In the last video, we understood what really AI Oops is and why it is the next big thing for DevOps. And I promised in this part we will start by designing the architecture blueprint of our AI Oops agent. So let us see how this intelligent system will work. Before going anything or starting anything, let's recall our challenge. The DevOps team get overloaded with alerts and logs don't always point the real issues. So what's our goal? Build an AI powered layer or I can say agent that can understand patterns, find root causes and send smart alerts. Hi everyone, I am Unnati Gupta. You are watching AI Oops with Unnati. On this channel, we explore how AI transforming DevOps from automation to intelligence. So, if you are a DevOps engineer or tech enthusiast, hit that subscribe button and join this growing community. Blueprint for the AI Oops. So before starting this blueprint for the AI Oops, I just want to come back for one step back. That is, as a DevOps engineer, when we start a particular project from the scratch, we design our services, which called applications, and that applications code is written by the developer. So I will say that stage is called code development. Yes, the first stage is code development. Then developer is developing the code and checking like testing in their local environments, in their laptop or in their PC. Then they are pushing the code on a particular platform, so everyone is able to access the code. Instead of sharing over the zip file, everyone knows these points. So that platform will might be GitHub, GitLab, Bitbucket. There's other tools exist in the market. I am just telling about some tools. So developer will push the code in that particular platform. After that, what a DevOps engineer will do, DevOps engineer will take the code from here and start building the pipeline as per the application. So pipeline, I will say pipeline build by DevOps engineer, build by DevOps person or DevOps engineer. In that he will consider, or that person will the DevOps engineer will consider the things which is required to build an application, whether it's Java application or whether it's Python, or there's a lot of other languages there. So based on the application we have to push the requirements and we build a pipeline. After building the pipeline, everyone see or everyone notice that there's a step that is called Docker file. We mentioned one Docker file that's used for building the Docker image. So, Docker file for creating Docker image. That is the main thing here. The Docker image, which is having all the things like all the requirements which is required to run a application like operating system, everything is there, versioning package, everything is there inside the Docker image. We have to simply use that Docker image and we can run the application on any VM or any other machine, I will say any other machine. So after that, creating this Docker image, what we are doing as a in our project, or what we will do in that project, like by using the Docker image, we will deploy the application over the Kubernetes environment, whether it is KTS architecture, KTS architecture, or might be it will be Docker based architecture. There's a lot of different type of architecture we are introducing in our system. So these are two architectures mostly people are using. So yes, after deploying the application, the application will run successfully and people like everyone is able to access that application. But the main point is coming, at the end when our project is live or might be using by our client, the main thing is that the monitoring, like how our application is working. If number of users is increasing, if number of users is down, it is working properly, how much CPU memory is required. So these things we need monitoring. That's called, we have been like we are using in that case we are using monitoring tools like Prometheus, Grafana, Loki, Flintwit. I'm taking some tools only, but you can use others like EFK and all. But I'm just taking back basic things like Prometheus. Grafana is the requirement to check the metrics like CPU memory, how much CPU is used, if number of users is this much over the our applications, and when our application is going down. So these things is managed by this Prometheus and Grafana. So this much is done as a DevOps engineer. And after that, what is happening, if application is live or something, what we are doing, we are using here alert manager also. Alert manager, which is sending alerts to us when our application is going down, or maybe CPU spikes is there, memory load is there, something is happening. Alert manager will send the alerts over the Teams or over any other application, I will say WhatsApp and all. It depends on us what we are designing in that. So but in that case, what's happening, alert manager will say CPU is spikes 60%, 70%, so application is down. But it is not telling the real issue. And sometimes it is very difficult to find out the issue. That is a big problem nowadays. Even not nowadays, every DevOps engineer or DevOps team is facing to make the application up. In that case, we have to what we are planning to come out from that situation. We will add one AI agent here. So I'm going to add one AI agent which will collect the matrices from the Prometheus, analyze them, and talks to AI. Now the question is how it will talk to AI. So in that case, I will add one MCP server. I hope you guys listen about this MCP server, or I will discuss in other video about this also, like what is the MCP server and all. So MCP server acts as the bridge between our agent and the LLM. LLM is large language model. So it will not come in this architecture diagram or blueprint, but as we can understand in the behind of the scene, the AI agent will collect the metrics from the Prometheus, and the what's happening, what AI agent will do. AI agent will go to the MCP server, and MCP server is working as a bridge between AI agent and the LLM, which will generate intelligent insights and store that insights we will store over the PostgreSQL DB also, like over the DB to find the fingerprints, or we will have our own data, what's happening, everything we will have. So I will add PostgreSQL DB. You can use any other DB also. It's not to use a particular DB. So whatever LLM will generate a particular message based on the matrices which is collect from the Prometheus. It will generate an intelligence message, and we will store that message over the PostgreSQL DB. And same message we will send to a particular notification app. It might be Teams, it might be WhatsApp, or something else. It depends on your choice. Microsoft Teams, I am taking Microsoft Teams, or whether you can put over the Telegram, Slack. So that's the way it will work. And why we are using this PostgreSQL DB, to avoid the duplicates also. Like pod is going down. Just imagine a pod is going down. What our AI agent is doing, our AI agent is continuously fetching the metrics from the Prometheus. So obviously, if pod is down, it might will take few minutes to make it up, or not a few minutes, might be few seconds to make it up. And if AI agents is continuously monitoring taking the collecting the matrices from the Prometheus, it will continuously notify to us, which sometimes become a trigger situation also. So in that case, before generating a notification, or before checking, AI agent will check over DB if it is existing, or the continuous, or we will check the timing also, like 5 minutes or 6 minutes or something, and it's not updated, whether we will update here, like it's running now, so we will close that query. Or if it is not updated, or it's continuously open, AI agent will not send the notification continuously to us. It will send in between, after like 30 minutes, 10 minutes, depends on our situations. So in this case, each component is playing a unique role. Like Prometheus is our eyes, Agent is brain, MCP server is reasoning power, and Teams is the voice. So if I make the diagram here, what's happening? The first thing is code development. Then it is going to GitHub, like a particular platform where we can take the code, or everyone can access the code. Then what is happening? DevOps engineer is taking the making the pipeline, build pipeline and any other things, other stages. Then after that, it is there's a file also, which is creating the Docker image. 1 minute. Docker image. Then it is going to Kubernetes architecture, or any other architecture where we are deploying our application. That is called continuous integrations through continuous deployment. Then monitoring, it is Prometheus Grafana. These are the basic things in DevOps, like DevOps project. Then we are adding a AI agent. So what AI agent is doing? AI agent collecting the matrices from the Prometheus. Then it is going to MCP server. MCP server is talking to LLM. Then LLM is generating a notification, or generating an intelligence message, which is going to the PostgreSQL DB. And from there, we are sending our a same message, which is generating by this LLM. We are checking firstly over the Prometheus, and then we are sending to Microsoft Teams. Okay, yes, that. So that's the way we will going to design this, the full architecture blueprint for AIOps. So in the next video, we will actually start building this agent in Python and make it talk to Prometheus and MCP for the first time. If you are excited to see AIOps in the action, hit the subscribe button. Stay tuned because real implementation begins next. And yes, don't forget to like, share, and subscribe. Drop a comment below and tell me which part of this AI oops architecture do you find more interesting. I would love to know before we start coding it together.